problem was 3.68, and for part A we were to find the flow rate. We knew that flow rate equals velocity times area, so we needed to find the velocity first and use Bernoulli's equation. We know at P1 it's a free surface, so we know the pressure is 0. We know at P2 it's also 0 because it's free jet, and then we know Z1 is 4 meters, as you can see by the height, and Z2 is 0 because it's at the bottom. And then we also know that V1, the velocity at point 1, is 0, again because it's at the free surface. And you can see our givens shown right here. From the givens being plugged into our equation, with the values that cross out, you end up getting gamma Z1 equals 1/2 rho V2 squared, and you know gamma equals rho G, so then your new equation is rho G Z1 equals 1/2 rho V2 squared. By solving for V2, you get 8.86 meters per second. Then, based on the flow rate equation, you know that it's area times velocity, and by solving for our area, we know the diameter is 0.10 meters right there. So going back to the equation, you have Q equals 0.0696 meters cubed per second, and that's your flow rate for part A. Problem, we had to solve for height h. We did so by using Bernoulli's equation from point 2 to point 3. From the Bernoulli's equation, we know that pressure at 2 is still 0. We know that height at 2 and 3 are the same because they're both at the bottom. We know V3 from the flow rate of the previous part, which is flow rate divided by A3, so you get your velocity at point 3, and velocity at 2 is also given from part A as well. Our reduced Bernoulli's equation becomes 1/2 rho V2 squared equals P3 plus 1/2 rho V3 squared. From rearranging, you end up getting pressure at 3 equals negative 56.66 kilonewtons per meter squared. Now that we have the pressure at 3, we use a manometer equation to find the value of h. We start at point 3, and through water we go up a distance of 0.08 divided by 2 plus the 2 meters, then we go down a distance of h in mercury. From the manometer equation, we have P3 minus the gamma of water times our distance plus the gamma of mercury times the distance and set that equal to 0. Since we already know the pressure from earlier, we set the two equations equal to each other and rearrange, and we end up getting an h value of 0.5746 meters, which is this h value right here.